Hello guys, my name is Abhay, and in this video we are going to learn how to name coordination compounds using IUPAC rule. To name coordination compound, first thing we should know is the type of complex we are naming, because there are different rules for different type of complexes. So depending on the charge present on the complex ion, coordination compounds can be divided into three types. Cationic complex. For example, hexamine cobalt chloride on ionization produces a complex with a positive charge. Such complexes which have a positive charge on them are called cationic complexes. Potassium ferrocyanide on ionization produces a complex with negative charge. Such complexes which have negative charge on them are called anionic complexes. If the complex has no net charge, then such complexes are called neutral complexes. For example, tetracarbonyl nickel, pentacarbonyl iron, etc. Next thing we should know is how ligands are named in coordination complexes. So bromide is called bromo, chloride is named as chloro, cyanide as cyno, hydroxide as hydroxo, oxide is called oxo, carbonate is named as carbonado, nitrite is called nitro, oxalate is called oxalato, ammonia is named as amine, carbon monoxide is named as carbonyl, water is called aqua, and ethylene diamine is named as it is, ethylene diamine. Now that we know how ligands are named in coordination complexes, we are going to start with cationic complexes. Cationic complexes are named in following order. First, we write name of the ligand by using prefixes like di, tri, tetra, penta, etc. Ligand name is followed by name of metal. Metal name is followed by oxidation state of metal, which is written in Roman number in brackets. And oxidation state of metal is followed by name of anion if it is present. Let's take an example. So we have cobalt ammonia chloride complex in front of us. First we are going to name ligand. Ligand is ammonia. Ammonia is named as amine. There are 6 ammonia groups. So we are going to use prefix hexa. So hexa, amine. Ligand name is followed by name of metal. So metal here is cobalt. So hexa, amine, cobalt. Then we have to write oxidation state of cobalt. But we don't know what the oxidation state of cobalt is. So let's calculate. So let's make an equation. Cobalt plus 6 ammonia groups plus 3 chloride is equal to 0. Now we don't know what the oxidation state of cobalt is, but we know ammonia is neutral and chloride has -1 charge on it. So let's make the necessary substitutions. We get plus 3. So oxidation state of cobalt is plus 3. We are going to write 3 in Roman number in brackets. Next, oxidation state of metal is followed by name of anion. So anion here present is chloride. So we are going to write chloride. When different type of ligands are present in the coordination sphere, we name those ligands in alphabetical order. So between ammonia and chloride, we are going to name ammonia first, followed by chloride. Okay. So name of the complex is pentamine, chloro, cobalt. Oxidation state of cobalt here is 3. So pentamine, chloro, cobalt, 3 chloride. In absence of an ion, we simply write ion next to oxidation state of metal. In case of polydentate ligands, where prefix like di, tri, tetra, etc. are present in the name itself, in that case the number of ligands are given by using different prefix like bis, tris, tetrakis, etc. Bis is used instead of di, tris instead of tri, tetrakis instead of tetra, and so on. For example, in the following complex, En is the abbreviation for the ligand ethylene diamine. Now, as di prefix is already present in the name, we cannot say diethylene diamine. So instead of saying diethylene diamine, we say bisethylene diamine. Also in this complex, there are 2 different ligands. By considering alphabetical order between chloro and ethylene diamine, we are going to name chloro first, followed by ethylene diamine. So the name of the complex is dichloro. As there are 2 molecules of ethylene diamine, we are going to use prefix bis. So dichloropis, ethylene diamine, cobalt. Oxidation state of cobalt here is 3. So dichloropis, ethylene diamine, cobalt 3 chloride. Next we are going to name neutral complexes. Neutral complex and cationic complex are named in the same order. So first we name the ligand, followed by name of metal, followed by oxidation state of metal. For example, here the ligand is carbon monoxide. As there are 4 carbon monoxide molecules, we are going to use prefix tetra. Carbon monoxide is named as carbonyl in coordination compounds. So tetracarbonyl. Name of ligand is followed by name of metal. So tetracarbonyl nickel. As carbonyl is neutral ligand, oxidation state of nickel is 0, so we are going to write 0 in bracket. Let's take one more example. So we have ammonia chloride platinum complex in front of us. In alphabetical order, we are going to name ammonia first. So as there are 2 ammonia molecules and 2 chloride molecules, so diamine dichloro platinum. Ammonia is neutral, but chloride has -1 charge, so oxidation state of platinum here is +2. Next we are going to name anionic complexes. Anionic complex are named in following order. First we name cation, followed by ligand, followed by metal name ending with suffix ate, followed by oxidation state of metal. So here is the table that shows how metals are named in anionic complexes. Please pause the video and go through it. Let's take an example. We have potassium ferrocyanide complex in front of us. In anionic complex, we name cation first. Name of cation here is potassium. Name of cation is followed by name of ligand. Ligand here is cyanide. There are 6 cyanide groups, so we are going to use prefix hexa. So potassium hexacyano. Metal here is iron. Iron is named as ferrate in anionic complex. So potassium hexacyanoferrate. Now let's calculate oxidation state of iron. Let's make an equation. Potassium plus iron plus cyanide is equal to 0. We know that oxidation state of potassium is +1 and oxidation state of cyanide is -1. By substituting these values, we get +2. So oxidation state of iron is +2. In absence of cation, we simply write iron next to oxidation number. So name of the following complex is hexacyanoferrate 2 iron. Let's take one more example. Here cation is potassium, ligand is oxalate, which is named as oxalato. As there are 3 oxalate groups, we are going to use prefix tri. So potassium trioxalato. Metal here is aluminium. In anionic complex, aluminium is named as aluminate. So potassium trioxalato aluminate. As oxalate has -2 charge on it, so oxidation state of aluminium is +3.